Hello everyone. Today we shall discuss about units and measurements. Chapter 1, the fundamentals of quantitative science. See here what we are getting here as that is units and measurement. Chapter 1, the fundamentals of quantitative science. The need for measurement. Measurement Measurement, the need for measurement. Measurement is the process of comparing a physical quantity with a basic, arbitrarily chosen, internationally accepted reference standard called a unit. Although the number of physical quantities appears to be very large, we need only a limited number of units for expressing all of them. Physical quantity is equal to numerical value into unit. Suppose length equal to 4.7 meter, therefore 4.7 is the numerical value and m is the standard unit. Evolution of systems. You see how the system evolves. Evolution of system. Number one is CBSE system. The length is measured in centimeter, the mass is measured in gram, and time is measured in second. In FPS system, the length is measured in foot, mass is measured in pound, and time is measured in second. In MK system, length is measured in meter, mass is measured in kilogram, and time is measured in second. And System International, that is SI system, developed by BIPM 1971, the internationally accepted standard for scientific, technical, and industrial work. SI uses the decimal system. Conversions are simple if we use the decimal system. You will find the 7 base units. The SI system has 7 base units: length, mass, time, electric current, thermodynamic, temperature, amount of substance, and luminous intensity. Length is measured in meter, symbol is m. Mass is measured in kilogram, symbol is kg. Time is measured in second, symbol is s. Electric current is measured in ampere, symbol is A. Thermodynamic temperature is measured in Kelvin, symbol is K. Amount of substance is measured in mole, symbol is MOL. And luminous intensity measured in candela, and the symbol is CD. The alphabet of physics, all of the units are built from these. Beyond the base, besides the base, we have two supplementary units. One is known as plane angle, and another one known as solid angle. Plane angle is measured in radian, and solid angle is measured in steradian. Now we have derived unit. There are two types of units. One is fundamental units, and number two is derived unit. What are fundamental units? Fundamental units are those units which are independent. They does not depend on any other fundamental units. And derived units are those units which are dependent on fundamental units. For example, fundamental length, mass, time. For length, we measure it by meter, mass is measured by kilogram, time is measured by second. So these three are needed to express derived units. Units expressed as combinations of base units. Base means fundamental units. Force in mass in acceleration, therefore kg meter per second square or Newton. Decimal mass by volume kg per meter cube. These are the derived units. And remember that derived units are dependent on fundamental units. Precision and significant figures. The result of measurements would report reliably known digits plus the first uncertain digit. Reliable digits plus first uncertain digit is equal to significant figures. You see here, this is 1.62. 1.6 is the reliable and 2 is uncertain, and therefore this is 3 significant figures. 287.5 centimeter, therefore reliable is 287.5 is uncertain. There were 4 significant figures. Precision depends on the least count of the measuring instrument. Rules of significance. All non-zero digits are significant. See 2, 3, 8, 0, 8. Therefore there are 4 significant figures. Zeros between non-zero digits are significant. Zeros between this is non-zero. Zero is between non-zero. Therefore, the 4 significant figures. Leading zeros are not significant. That means after point, the zeros are not significant. It is 1, 2, 3, 4. four significant figures. Leading zeros, that means underline 2, 3, 0, 8. Only four significant figures 2, 3, 0 and 8. Trailing zeros without a decimal are not significant. So here for there is only three significant. These trailing zeros are not significant figures. Trailing zeros with a decimal are significant. Trailing with a decimal, therefore there are zeros convey precision, right? So these zeros are trailing zeros with decimal are significant. These are the rules of significance. The scientific advantage. So if we use a scientific advantage, we can use the basic more important things as we can express it as significant figures. For 4.7, how many significant? 4. If we write in centimeter, the significant figure is 4. If we write in millimeter, significant figure is 4. If we write in kilometer, even the significant figure is 4. So you have to write in scientific notation so that we can change it into scientific into significant figures. In every case, there are 4 significant figures. The power of 10 is irrelevant, right? Now we'll get this one. Arithmetic multiplication and division. Rule: the final result should retain as many significant figures as the original number with the least significant digits. Worked example: mass is this, volume is this, density equal to mass by volume 4.237. If we divide, we get this value. So around 3 significant, we are getting 1.69 gram per cubic centimeter because limiting factor is 3 significant. The least, it is said it is least. So the least 3 significant figures is 3 significant figures. Arithmetic addition and subtraction. The final result should retain as many decimal places as the number with the least decimal places. Same as that, addition and subtraction also. If we add this one, we are getting this one. So 663.8 gram. Limiting factor is 1 decimal place. You see, this is 1 decimal place. Therefore, the result is 63.8 gram. This is the answer, right? Now we are getting to the next one. You see this one. The art of rounding. How to round off? Drop digit less than 5. Leave the preceding digit unchanged. That is 2.743. You see here the digit is less than 5. Therefore, it will be same 2.74. Drop digit greater than 5. Raise preceding digit by 1. 2.7466 is greater than 5. Therefore, it will be 2.75. Right? The rule of 5. What is that? If the digit to drop to drop is 5, the preceding digit is even, leave it. 2.745, therefore 2.74. This is the rule of 5. 2.74. If it is even number and preceding digit is odd, before 5 it is 3, therefore we have to change it to 4, 2.74. This is the rule of 5, right? Now we'll get to the next one. That is this one, the dimensions of physical quantities. We know that the length is expressed as capital L, mass is expressed as capital M, and T is expressed as capital T, and these are the dimensions of a physical quantity. Suppose volume, a length into breadth and height, L cube. Suppose force, mass into acceleration, M, L to the power T to the minus 2, M L T to the power minus 2. So these are the dimensions of a physical quantity. Magnitudes are ignored. Initial velocity, average velocity, and final velocity are all shares of dimension L T to the power minus 1. Dimensional consistency principle. This is very much important. What is the principle of homogeneity? You can only add or subtract quantities with the same dimensions. X will x0 plus b0t plus half at square. See, the dimension of x is L, x0 is L, dimension of b0t is also L, and half at square is also L. So dimensionally this formula is correct. L equal to L plus L plus L, right? So you can only add or subtract quantities with the same dimension. Reducing relations problem. Derive the period t of a pendulum depending on length, mass and gravity. So t is equal to k, L to the power x, g to the power y, m to the power z. So t is equal to L to the power x, L to the power minus 2y, m to the power z. Equate powers. Z equal to 0. You see, z equal to 0, x plus y equal to 0, so 2y equal to 1. So therefore, you are getting y equal to minus half and x equal to half. So you are getting t equal to k, L by g. But you have to remember that this k cannot be found out. Value of k, 2 pi, must be found out by experimentally. With dimension, you cannot find the value of k, and that is the drawback of dimension. The physicist toolkit, SI units, the standard, right? Significant figures, the precision, dimensions, the logic. So a dimensionally correct equation need not be exactly right, but a dimensionally wrong equation must be wrong. Thank you everybody for watching this video.